Hi everyone, welcome back to the channel. My name is Drew. I'm an exercise physiologist and Chinese medicine practitioner, and I love all things breathing. I've been studying and practicing qigong and yoga and pranayama and breathwork for a long time, well over 20 years, and also as an exercise physiologist helping people with exercise recover and perform and train and be fit and do all the fun things. And in this video, we're going to be looking at nasal breathing during exercise. And a big shout out to Anne Mack, who asks the question, what is the best way to breathe during running? I know Anne's a mad, keen exerciser who loves her running. So hopefully in this video, we'll give you a bit more insight into the benefits and the cons, the pros and cons of nasal breathing during exercise. So let's get into it. Get yourself a nice cup of coffee, glass of wine, or a whiskey, whatever is your choice, and let's go. So nose versus mouth breathing. Essentially, you've got three options when you're breathing. You can breathe in through your nose and out through your nose. You can breathe in through your mouth and out through your mouth. Or you can do any kind of combination, and there's a couple different combinations. So you could inhale nose, exhale mouth, or inhale mouth, exhale nose, or inhale nose, exhale mouth, inhale mouth, exhale nose. Okay, so you've got different kind of combinations that you can practice or do when you're breathing, and they all actually have very subtle different effects on the body and the physiology, which is interesting. In terms of nose and mouth breathing during exercise, the key variable is resistance. So how do we get air from the external environment into the lungs? That's what breathing is about, or what we call ventilation, is the moving of the air in and out of the lungs, and how we optimize that. So we're going to be talking more predominantly about ventilation today. So let's compare the nasal cavity to the oral cavity, and we'll break them down. And basically, when you study anatomy and physiology, it explains the function of how things work. So the anatomy, the structure, often structure kind of dictates the function, and then the physiology dictates how things work. So in this case, the anatomy, the structure, the skeletal bone placement will kind of illustrate how breathing works. So in the nasal cavity, we have a very complex narrow passage divided by the nasal septum into two channels. So basically you got your left and your right nostril, and then you got the kind of the little kind of cartilaginous kind of bone down the middle, and that separates the two. Aligned with the turbinate or the conch, bony structures covered in mucous membranes that increase surface area for air filtration, humidification, and warming, but reduce the open airflow space. So the conch is, think of kind of like a seashell. It's got like a bit of a spiral kind of shape to it. So instead of having a big round hole that the air moves through, it's kind of got these spirals that they have to move through, which circulates the air, but also gives air more contact to the surface of the bone in the nose, which means there's more contact into those mucous membranes, which is a big part of the kind of the first line of defense in terms of your immune system, because it's going to kind of capture any particulates, any kind of bacteria or viruses. That's the first place it's going to enter, and so the kind of the mucous membrane is a big part of your immune system at that level. The average cross-sectional area of the nasal passage at its narrowest point, the nasal valve, so that's basically the opening of the airway where you'd stick your finger in when you're picking your nose, is about 0.3 to 0.7 centimeters square per nostril, and depending on the individual anatomy and congestion rate. So if you're quite congested, if you're very phlegmy, that's going to decrease the ability of the airflow to come through, because the phlegm's going to decrease the space. And different individuals have different sized nose, and we know that females tend to have bigger nasal cavities, so bigger noses, and also people from kind of like African American descent as well have bigger noses. In fact, the London 2012 Olympic Games, there was an athlete who won the, I think it was the 400 meter or 200 meters sprint, and he did it all nostril breathing. Okay, and he's kind of like one of the big first elite athletes to kind of bring kind of nostril breathing into the center stage, and we'll talk a bit more about how that works later. So the total airflow is constrained by this bottleneck in the nasal valve, which increases the resistance of the air moving in. Now, if you look at this kind of nasal valve surface area of 0.3 to 0.7 centimeters squared, in the oral cavity, its cross-sectional area varies wildly with the mouth, but when it's open, it can exceed 10 centimeters squared. So it's 10 times bigger when fully open or large. Now, you're not going to be running with a fully open mouth, so it's not 10 times more air moving in and out, but it's a substantially bigger airway. Okay. The oral cavity encompasses the mouth, the throat, and offers a wider and less obstructed pathway for the air to move through. Even with the tongue and the soft palate in neutral position, the oral airway is broader and less tortuous than in the nasal cavity. So tortuous meaning that the airflow can move in and out a lot more smoother without that resistance. So let me jump on to one of my anatomy apps to show you a bit more of the nasal passages. That's not what we want. Here we go. Oh, that's my emails. You probably don't need emails. Where are we? So here we go. So we have the nasal cavity and so if I click here onto nasal cavity, here we go. I'm using two monitors, so it's a bit tricky sometimes to navigate. So the blue is basically the nasal cavity. Now the key thing to note here is that here is the nasal valve, this little hole here. So you have to get your air in through this basically hole through here, that 0.3 to 0.7 centimeters squared space. So you don't have a lot of space to get the air in. Now the actual nasal cavity is quite large once you get it in there, but moving it through there is quite difficult. And then you have the turbinates to deal with as well, which I might be able to show in a second. And then we have the oral cavity, which is, if I can get it, click on the actual, that's the oral cavity there. So the mouth, okay, and then we have here the oropharynx and the larynx, which kind of makes the throat into the trachea, or the windpipe coming down through here. And so in the nasal cavity, you get this big kind of airway or pipe here. It meets with the oral cavity here, becomes one airway. Okay. There's a little valve here called the epiglottis, which if you swallow food down, it has this really unique kind of valving function, which kind of directs the food down here, down to the stomach. And when you're breathing in, it opens and the air comes in and out through here, which is interesting. So in yoga, in pranayama, we do what's called valving techniques to kind of manipulate or optimize this kind of valving with the windpipe and the voice box by humming or making a sound. And that's another really cool little aspect of breathing, which we'll talk about in another video. So that's kind of the nasal cavity. And let me see if I can show you that's the connage there. So that's the bone. So can I fade others? So you can kind of see it sits on the side there. And as you breathe in, it's going to kind of create more turbulence and circulate the air. Let me jump onto complete anatomy. It's a better view on a complete anatomy. So we'll pop that one up. Okay, here we have the skull, and these green ones here, these are the turbinates here. You can see where the air would move in through between the bones, and so then that creates more of that surface area, more resistance, and circulates the air. So it just makes it harder to get air in through the nose. So it decreases that surface area, or increases the surface area, but it decreases the space where the airflow can come through. So you have this kind of anatomical structure, which is really important. Now, if you've had a broken nose, or if you had a facial fracture where these bones have been involved, might have different shapes. You can get individual variations. Some people have larger than normal turbinates, and so that reduces the airflow as well. And then some people are susceptible to a lot of mucous membrane and inflammation, kind of sinus inflammation type issues, and that'll all decrease the airflow coming in and out of the nose. So sometimes it's a skeletal structure thing, sometimes it's like a reaction, like an autoimmune reaction, like an allergy, which is producing more mucus. And so we kind of need to figure out what's the issue there that's causing people to have reduced nose breathing capacity. All right, go back to our slides. Next slide. So here we have our turbinates, just looking from the side again. So you're going to breathe in through the nose, like the nostril, and then you've got these different layers of the turbinates, which is going to create that swirling, and then it goes back down here into the oropharynx, down through the back there. Okay. 4 roles that the turbinates have. Okay, warming and humidifying the air. This is really super interesting. Regulating airflow. So the inferior turbinate regulates airflow by swelling and contracting to maintain appropriate moisture levels within the nasal cavity. This process is controlled by underlying erectile tissue containing venous sinusoids, adjusting turbinate volume based on autonomic stimulation. So that's something you don't have conscious control of. In most individuals, one inferior turbinate swells while the other one contracts, directing most airflow through one nostril at a time. The alteration, known as the nasal cycle, lasts from an hour to 6 hours, with longer cycles during sleep. So it's really amazing. So essentially, as the body is kind of like sensing its needs for different kind of blood gases, carbon dioxide and oxygen, part of the way it adjusts that is by just valving, so slowly increasing or decreasing the space in the actual nose through left or to the right, so you're getting this nice balanced airflow in and out to meet the demands of the body, which is super amazing. It's a pretty cool little function. The third thing it does is immune function. So first line of defense is breathing through your nose. When you breathe through your mouth, you don't get that. And then we also have sense of smell. So that's your olfactory bulb sits on the back there. So when you breathe in, it's going to stimulate cranial nerve 2, which is your smelling nerve, and that goes into kind of regions in the limbic system and different aspects of the brain. So 4 things: warming, humidifying the air. You want to think you don't want to have dryness in the lungs or in the airway because dryness restricts the flow of air. You want it slightly moist. And in the lungs, particularly in Chinese medicine, lungs do not like to be dry. It's kind of like one of our key questions we'll ask someone: do you feel hot or dry in the lungs? And what we try to do is keep the lungs moist, and that's really orientated around what you're eating and nutrition particularly, and also your environment that you're in. So just something to be aware of there. Okie dokie. So let's get into some nuts and bolts here. So let's look at ventilation, or VE, in litres per minute. So this is how many litres of air you can get in and out of the lungs in a minute. So minute value ventilation provides the air needed for oxygen uptake. So essentially, the first step in fitness or breathing is you got to get the air into the lungs. Okay, once the air's in the lungs, then we extract oxygen from the air at the respiratory membrane. That goes, oxygen then goes onto the blood, onto the hemoglobin, binds to hemoglobin. Hemoglobin acts like a little Uber and then circulates around the body via the circulatory system. And then wherever the cells or tissues need oxygen, it gets kind of drawn into the cell through diffusion, and then it goes into the energy production process to create cellular energy called adenosine triphosphate, or ATP. So every cell needs ATP to fuel its function or its job. So the better we can get air in and deliver oxygen to the tissues, just the healthier we are, because the cells will have enough energy to do their job, and they're getting enough of that oxygen. Oxygen is energy in a sense. So when you're trying to work on fitness, there's two key things in fitness. There's ventilation, so how much air you can get in and out, how good your breathing is, and then how well you use the oxygen, you utilize it in the muscles, particularly during exercise. That's called VO2 max. So here we're looking at ventilation. Okay, so just the air in and out. So in a rest condition, breathing through your nose, you're going to breathe between 5 to 7 liters per minute. In a rest condition, breathing through your mouth, you're going to breathe 6 to 8 breaths per minute. So at rest, nasal breathing is definitely preferred. Even though you can get more air in with your mouth, okay, because of the lower resistance, there are a lot of health benefits breathing in through your nose because of that humidifying component, that warming component, the autoimmune or the immune system component, stimulating gas nitric oxide, which is cardiac protective, so it's a vasodilator, so it's really good for your heart and lungs. So you get all these other health benefits when you're breathing through your nose. When you breathe through your mouth, you don't get those benefits. Okay, so we typically like to encourage people when you're at rest or in low intensity exercise, you're nostril breathing. Okay, the resistance breathing through your nose is 2 to 3 times greater than when you're breathing through your mouth. So it's easier to breathe through your mouth at rest and during exercise, just because the resistance coming through the actual airway is so much greater through the nose. However, that is trainable, and we'll talk about that again a bit in the presentation. Okay, just kind of park that in the back of your mind for now. Now, exercise, when you're exercising, you can move between 10 and 30 litres per minute in and out of the lungs. Okay, at moderate to maximal exercise, 20 to 100, that's a lot, 100 litres of air moving in and out of the lungs. Okay, so that's maximal exercise, around 100 plus. So it's a big difference between 30 up to 100. So a huge amount of air that can get in and out. Now, the big question is it just because you're getting more air in and out of the lungs doesn't mean you're actually utilizing the oxygen well? And so that's going to be the big question, is there a difference in how we use the oxygen when you breathe through the nose and through the mouth? And we'll kind of get to that as well. So typically, mouth breathing or oral breathing dominates in high intensity exercise, particularly once you cross that anaerobic threshold. The oral bypasses the nasal filtration, humidification, and potentially drying the airways. Dry airways are one of the symptoms of, or kind of causal links to, some asthma-based conditions as well. So something to consider as well. So if you've got a history of asthma, okay, one thing to consider is learning how to do some nostril breathing, and there are some other really important kind of reasons why you do that, kind of orientating around blood gas regulation, which we'll get to. All right, a bit more detail. So, assuming we're like working with a 40-year-old male, focusing on nasal breathing versus oral breathing, okay, during exercise. So during the nose breathing exercise, 10 to 30 litres per minute, light to moderate exercise. Once you get to around that kind of like 10 to 30 litres per minute, it's going to be limited, and that's roughly going to be your anaerobic threshold. Anaerobic threshold is when you kind of make that big shift from aerobic, meaning with oxygen, to anaerobic without oxygen. So that's that big shift. As you get better trained and fitter, you can push that number up a bit higher. So there's a training effect that definitely happens. But essentially it's going to be that switch, which is going to sit around 50 to 60, 65% of people's VO2 max. So if you're looking at like a heart rate, so that's going to be somewhere around your 65% to 70%. Again, depending on how well you're trained. Okay. So as you're exercising, the metabolic demand increases, so you need more oxygen into the tissues, and then you'll also need to exhale carbon dioxide, which is a process of creating oxygen. I don't like to call it a waste product, but it's not wasteful, it's just a part of the process. And carbon dioxide is really, really important. Okay, so as you are increasing the intensity, the more gas you're moving in and out, and the more carbon dioxide you're going to have to exhale. At some point, the smaller airway through the nose isn't going to be able to keep up. It's going to get obstructed, and then you will switch that's often called the switch point. And the switch point is trainable, so with practice you can make that switch point delayed. So instead of like maybe getting your switch point at like your 50% of your VO2, with training maybe you can bring it up to 60%. So you delay it, which means then you're training or working more efficiently before you make the switch. At least that's the theory. There's kind of research happening now to kind of see if that's actually true, or if it's a component of it. So stay tuned. But that's kind of the theory, the thinking that's in the space at the moment. So contribution to nasal breathing, it's dominant in the light exercise. So in your light to moderate kind of or endurance-based exercise, nasal breathing is very, very beneficial because it's very efficient, and you can keep going with it. As soon as you get over that aerobic threshold, that's when things start to kind of switch back. So the limit then is going to be that kind of an anaerobic threshold limit if you're not trained, or slightly higher if you are trained. Versus mouth breathing, ventilation 20 to 100 litres per minute, so huge difference there. Oral breathing dominates moderate to high intensity exercise due to the lower airway resistance, allowing higher airflow to meet increased oxygen demands at peak exercise. Ventilation can exceed that 100 litres per minute in fit individuals, primarily via the oral cavity. So it's going to be a combination of nose, mouth, but as you get training harder, you're going to go mouth. So you'll often hear when you're training people or coaching, you kind of start going nose, and then nose, mouth, and then mouth, and then when you're recovering, you kind of reverse it. You're recovering, you go mouth, then nose, mouth, and then nose. So you kind of like scale it. And the kind of thinking behind that is you want to then kind of rebalance all the blood gases as quickly as you can. So you bring your pH back to those kind of like 7.4 level, that kind of normal level. And that's where the body loves to be operating. So hypoventilation, so not breathing enough, or hyperventilation, over breathing, that will change the pH balance. And if you go too far either way, the basically production of energy in the cells gets diminished significantly. So when you are recovering, you're trying to use your breathing to kind of restore that pH as quickly as you can, as part of the mechanism. Okay. All right. So if you want to look at the values here, so Clinical Journal of Sports Medicine, 1992. I think I've got that here in the studies section. So let me go to, normal values and ranges for ventilation, breathing patterns at maximal exercise. So if you're interested, you can kind of jump on and read the study. It's open source via PubMed. You can kind of nerd out on that if you want to go a little bit deeper down the rabbit hole. Also looking at anatomy of the head, neck, and nasal conch through the National Library of Medicine. So again, this is free, it's open source, so you can kind of get a little bit more detail into the anatomy of the nasal conch in the turbinates, which is where I'm drawing that information from, even up to the nerve supply, sympathetic innervation. Variants here, there are people who have 4 turbinates versus 3. So you definitely jump on, check that out if you want a bit more. And then we also have the switching point. So the switching point from nasal to oro-nasal breathing. Okay, and when you read through this study, essentially it's going to hover around that anaerobic threshold point, which kind of makes sense. Now it's interesting because one of the big kind of questions is like these studies are quite old. So we've got 991, and then we've got when's this one to come out? This is quite new, but this is just like basics, anatomy and physiology, the effects of nasal breathing. We'll get to this in a minute. But like the kind of classic old studies, the normal value ones and the switch point. Okay, in 1980s, 1960s, like really early studies, and when they were looking at exercise, they could clearly demonstrate that you could breathe a lot more. So I'm just trying to get the slide back. You could breathe a lot more breathing through your mouth, and the VO2s matched that. And so it was basically settled science saying, okay, if you want to train really hard, essentially it's mouth breathing is the go. What we're kind of understanding now is it might be an adaptation phase where you train the body to tolerate increased levels of carbon dioxide in the body. Increased levels of carbon dioxide is really interesting because we might as well start talking about the nasal breathing paradox in Professor Dunham's work. So essentially, the process of making energy in the cell, you release carbon dioxide back into the blood. So as the blood increases carbon dioxide levels, it decreases your pH, increases acidity, so you become more acidic. Now, as you increase acidity and you increase carbon dioxide levels, it signals the blood to release more oxygen. So as your CO2 increases, you release more oxygen from the tissues and they kind of go into the cell, so they diffuse across. So as you increase your tolerance to breathing and building up your carbon dioxide, you get more oxygen moving into the cell through this kind of diffusion law, which is super interesting. You add into the piece then, nasal breathing stimulates the release of nitric oxide through the endothelium in the sinuses. It goes into the lungs and then systemically as well through the cardiovascular system, which are vasodilators. So then it opens up the airways, so you get bigger airways, so dilated airways. And then you also get dilated arteries and vessels, so you get more blood flow. If you know how to breathe correctly and you're breathing through your nose, you get more air into the lungs, so you maximize your inhalation phase, more air into the lung, and then you get more diffusion and becomes more efficient. And so then you're loading up hemoglobin with oxygen, but also at the tissue level, you're also releasing oxygen from hemoglobin because of those high CO2 levels. And so you become more physiologically efficient and economical, so then you don't have to breathe as much. So instead of breathing let's say 30 breaths a minute, and you now may only need to breathe 21 breaths per minute or 22, because it's not so much about how much air you can move in and out, but it's also how well you're using it. And so the physiology piece is important, and so when you're breathing through your nose, you're going to enhance that effect. Now the issue is when you get to a certain level, as you are building up that CO2 tolerance and you're decreasing your pH and making it more acidic, at certain ranges in pH, cellular function kind of stops and breaks down, and so then the body automatically will then kind of like make you exhale through the mouth to release excessive CO2 buildup as well. So then there are safety mechanisms in the body, and there's a psychological component to that of you're building up this kind of gas, you're feeling like you are almost suffocating, but you're not. You've got plenty of oxygen in the system. It's more about the build-up of ventilation. You can think of a container, you're getting more gas in the same volume of the container, so there's an increase in pressure. And so you've got to psychologically manage those sensations as well. So there's a kind of mental training component to breathing and nasal breathing and exercise, which people need to manage, and it needs to be done in a very slow, progressive way. So if we look at kind of Professor George Dallam's work, who's a really great exercise physiologist, triathlete, he's been doing early research on this for over 20 years now, so he was really ahead of the curve, and he has kind of shown, or he's demonstrating, that there is an adaptation phase or a training phase to nostril breathing, and a big part of it is training the diaphragm or the respiratory muscles. So if I go back, so we have the diaphragm here, and then we also have the intercostals, which sit between the ribs. So when you inhale, we want to increase the volume of the lungs, okay, because air will move from a state of high pressure to low pressure. So as you inhale, the pressure in the lungs decreases, so the air from the external environment goes into the lungs, high pressure to low pressure. So the bigger you can kind of make your chest and inhale, the more air you'll draw in. Now, because there's more resistance in the nose, it's easy just to breathe in through the mouth. But if you force yourself to breathe into your nose, what you can do is you're going to create a stronger mechanical pump with your diaphragm intercostal, so you get a training effect in the muscles of the diaphragm. And so the diaphragm itself gets stronger and it can draw more air in. So for each breath, you're getting more air in and more air out. So your pump, your mechanical pump, becomes much more efficient. So there's a whole nother piece in terms of the biomechanics of breathing and how to position your posture and your spine, how to use your abdominals correctly to kind of facilitate the mechanical pumping action of the diaphragm. And when you learn that, you can make your breathing a lot more efficient, particularly in low to moderate intensity exercise states. And then you can also use that for other things like lifting weights, yoga, Pilates, core training, all that kind of stuff, because core training is breathing and breathing is core training because of the interconnection between the abdominals and the respiratory muscles, which we'll get to in another video. Right, that's a whole other kind of thing we need to kind of consider. So you'll get respiratory training muscle effects. So you might see people wearing those respiratory masks, the training masks, and they do actually have a really good role in training the respiratory muscles. The key thing is, like, if you're still breathing through your mouth when you're wearing one of those masks, you're not really getting the benefits of nasal breathing. You're just training your mouth to breathe in more. So if you're getting one, make sure you get one that covers the nose. You can breathe in and out through the nose, and maybe even keep your mouth closed while you're doing it. So you're overcoming the resistance of the airway in the nose by using a stronger diaphragmatic contraction. So if you're interested in this kind of topic, I really recommend George's book, The Nasal Breathing Paradox During Exercise. Goes into a lot of the science, his research, what he's doing, really quite in depth. I highly recommend it. You can get it on Amazon pretty easy. It's about $50, well worth it. And just kind of like from his synthesis of evidence from one of his papers that he's released here, the effect of nasal breathing versus oral and oronasal breathing during exercise. So that's a great study. So that one is going to be, where is it? This one? Yeah. So I've just pulled off the kind of out of the benefits here that's in the paper. Okay, so just give credit to George's work. This is not my work, this is George's. We'll come back to the slides. So exclusively nasal breathing is feasible for most people at moderate levels of aerobic exercise without specific adaptation. So you don't need to go really hardcore training. You just basically close your mouth and start breathing in and out through your nose, excluding you've got in those kind of anatomical structural problems or lots of phlegm. Your body will just kind of naturally adapt it over a period of weeks pretty comfortably. This breathing approach may also be achieved during heavy and maximal levels of aerobic exercise following a sustained period of use. So heavy maximal levels of aerobic exercise. So that's training up to your VO2, your anaerobic threshold. So when you're at your anaerobic threshold, you're training very, very hard. So that's kind of like VO2 max training. You can typically sustain that for around 15 and 20 minute efforts. So I think a really quick 5K run, depending on how quick you do the run, like pushing hard, breathing hard, but you can do that through your nose. We also have here a reduction in exercise-induced bronchoconstriction. So I have a personal story of this one, which I'll share. So I'm in a group fitness instructor, cycle, RPM, spin class instructor. I've been teaching spin classes for well over 20 years now. And it's my kind of cardio of choice. I really, really enjoy it. It's great fun, good music, good people, get you fit. Yeah, it's just cool. And when you teach a class, so for example, I taught a class today, which is a 45-minute class, you're essentially, because you're riding it with everyone, so whatever all your participants doing, you're doing, typically at a higher level, you'd hope so, or at an equal level of intensity. But you're also coaching as you're doing it, so you've got to be able to speak and ride. And in most spin classes, it's a combination of aerobic, so slow and steady, cruisy paces, and kind of high intensity kind of intervals. So breathing really heavy, quite hard, quite physical. And essentially what I was doing was I give myself kind of like a bronchoconstriction or a form of exercise-induced asthma, where because you're talking all the time, you're outgassing a lot of the carbon dioxide. And if you overbreathe carbon dioxide, essentially what you do is you have the reverse effect of pulling oxygen into the tissues. So oxygen is released into the cells based on the level of carbon dioxide in the blood. And if you're excessively overbreathing and you're not rebalancing the breathing during your exercise, essentially you can have good oxygen saturation in the blood. So there's oxygen on the blood cells, but there's not enough CO2 to signal for the oxygen to release. And so then the tissues aren't getting supplied with oxygen, and they essentially kind of get a hypoxia in the tissues, and then they stop working, they shut down. And so I was getting really, really bad chest pain, kind of like felt like I was having heart attack type chest pain. Went and had all the exercise stress tests and all the things, and heart was fine, lungs fine, there was no issues there at all. And what I figured out over time is that I was overbreathing, basically inducing an exercise form of bronchoconstriction, and then so instead of having the airways open and they all constrict, giving yourself essentially asthma, which is really, really not cool. So I had to stop riding for probably a good 2 years, and then when I figured that out, reintroduced nasal breathing. And so today when I taught the class, I would say probably a good 7 minutes in the class I'm breathing through my nose. Of course I'm coaching, but I had to change my coaching so I don't say as much. But when I do my own training, I can pretty much do now the entire 45 minutes on the bike, aerobic and plus the intervals, with probably 9% nostril breathing. The real maximal efforts I will kind of switch to that kind of mouth breathing, and then introducing kind of mouth, then nose, then nose breathing during the rest intervals to rebalance everything, and works really well. Currently in the process of doing that for running. It's a work in process, mainly just because of some other injury that I've had, got a back issue from running, which is weird. Anyway, so adaptation was happening, but injury kind of slowed me down in that sense. But I could feel the difference happening there as well. And the kind of concept is, as you get more efficient with your breathing, you don't need to breathe as much to get the same amount of work or the same amount of energy, which is where we get improved ventilatory efficiency and a lower physiological economy. So basically you can work at the same level but not breathe as much, which is pretty interesting. We need a lot more research on this. This is really still the early stages of research, because we thought this is settled science. Basically, no one had bothered to kind of come back and look at it. Now, as the breathwork has become really, really popular, things like Oxygen Advantage, the Art of Breath, even the Wim Hof stuff, which has some issues in terms of exercise, has kind of really brought it to the forefront. We're having people doing marathons, nostril breathing. We've got gold medalists in London Olympics 2012, nostril breathing. We've got people climbing Mount Everest base camp, nostril breathing, all kinds of cool stuff. And people are just feeling and expressing and communicating that it's really helpful for them. It's really beneficial. It's great for their health. And we can certainly kind of start to map out some of the potential health benefits from nasal breathing during exercise. So the take-home message here is going to be low to moderate intensity exercise, nostril breathing. You'll need to train to be able to do VO2 max training. So like at the anaerobic threshold, you need to train for that. It's an adaptation phase that happens around the 6 month mark. Anything beyond that, you're in anaerobic training, and you can't sustain those for very long anyway. So glycolytic pathway, you're looking at maybe 3 minutes. So potentially you can nostril breathe during anaerobic training, but it will depend on your training, your different anatomical structures, and that. So there's it depends, lots of individual variation. That's why it's important to work with a good coach, a good exercise physiologist, someone who kind of knows what they're doing and is experienced. If you introduce nasal breathing with people, you can induce panic attacks on people. So definitely check in with your healthcare provider. And you can also, if you do it incorrectly, you could induce that kind of bronchoconstriction if people haven't adapted to it sufficiently, so it can backfire. So it needs to be done in a very kind of mindful, very progressive way. But the health benefits, particularly around the nitric oxide benefits, which is like just an amazing molecule which has antiviral, antibacterial, antimicrobial benefits. So it's great for your immune system. It's cardioprotective, increases cerebral blood flow. There's a whole range of benefits from nostril breathing, which stimulates nitric oxide, which come with that as well. So when you start to experiment with it, you will start to feel and experience the differences and the change in your own life, hopefully. And if you're not, there's probably something going on. You might be too mucousy, you might have some structural stuff going on, there might be some biomechanical issues where you don't know how to breathe correctly. So again, if working with someone can really help you kind of navigate through that. If you have any questions, drop them down into the comments. Always happy to answer them. And Mac, I hope this helps answer your question. Definitely check out the nasal breathing paradox during exercise by Professor George Dullum. He's really, really great researcher. He's got some exciting studies coming in the pipe, which I'll look forward to report on when they are out. And keep learning, keep training, keep studying, breathe through your nose as much as possible, and we'll see you on the next one.